class. Sorry for the lateness. Got up later than I thought it was. Told you there was going to be homework. And homework was 104. Solid sample of zinc hydroxide is added to 0.4 liters of 0.5 molar aqueous hydrobromide. The solution that remains is still acidic. It is then titrated with 0.5 molar sodium hydroxide solution. And it takes 98.5 milliliters of sodium hydroxide solution to reach the equivalence point. What mass of zinc hydroxide was added to the HBr solution? So what's happening here is you have it's called a back titration. Actually, it's not a back titration because when they added the zinc hydroxide, it did not fully neutralize the HBr. But then what they do is they finish the titration with a base that only gives one equivalent of hydroxide. So the remaining, it's basically two titrations. You're calculating two titrations here. So we have to find out the total amount of hydroxide used. To simplify, find out the total amount of hydroxide used, and that's going to tell you how much of the acid you had. Then you'll be able to subtract the amount of sodium hydroxide that was added to find out how much of the hydroxide was contributed by zinc hydroxide. Holy smokes, what the heck was that? Mama, what are you doing? Oh, I know what happened. A glass bottle that I put away in the garbage. I guess it was precariously balanced, and it fell, and it made Mama jump. It made me jump too. Now he's investigating. Okay, so just don't forget to check in, please. Let's start by writing what the equation looks like. So you're starting off with HBr, and you have 0.4 liters of it, and its concentration is 0.5 molar. It's being titrated with zinc hydroxide. And what you get is zinc bromide as precipitate. I'm guessing it's not soluble, and water. But they're also going to be using no, you gotta leave Mommy alone. She doesn't want you waking her up. Go on the balcony or something. Go there. Well, go the other way. Come on. Go. Leave Mommy alone. Come on. Go that way. All they say about this is solid sample. So you don't know how much it weighs. They don't even tell you that. But they do say that they do make an additional addition of sodium hydroxide. Well, let's find out how many before we start do anything, let's find out how many moles of protons have to be titrated. So, molarity equals number of moles over the volume. We are looking for number of moles, so molarity times volume gives you the number of moles. The molarity is 0.5. The volume is 0.4 liters. So what you get is 0.5 times 0.4, which is going to be 0.02 moles, I think. 0.2, sorry. So now let's find out how much sodium hydroxide was added to finish the titration. They say 98.5 of 0.5. So that's going to be, again, you're going to use the same formula, MV equals N, 0.5 molar times 98.5 thousandths of a liter. That's going to tell you 0.5 times 0.0985 gives you 4.925 times 10 to the minus 2 moles of NaOH. Okay, now subtract that number of moles from that number of moles, and that's going to give you half the number of moles of zinc hydroxide, because remember, zinc hydroxide gives you two equivalents. All right, so I'm going to say 0.2 minus 4.925 times 10 to the minus 2 gives you 0.15075 moles of HBr. Was titrated by zinc hydroxide. But remember, the stoichiometry is that for every 1 mole of HBr, you need, for every 1 mole of zinc hydroxide, you need 2 moles of HBr. So it's going to be 1 mole of zinc hydroxide titrates 2 moles HBr. That allows you to cancel moles of HBr and divide that by 2. And what you get is 7.5375 times 10 to the minus 2 moles of zinc hydroxide. Now all I have to do is multiply by the molar mass of zinc hydroxide to find how many grams of zinc hydroxide that equals. So let's do that. Don't remember the molar mass of zinc. I gotta look it up. Zinc is 65.39. So times 65.39 plus 2 times 15.39 is 4, that's the oxygen, plus 2 times 1.00794, that's the hydrogen, grams per mole. Let's find out what that is. 65.39 plus 2 times 15.39 is 4, plus 2 times 1.00794 gives you 99. So it's like saying times 99.39388 grams per mole. That's how many moles of it you need. So multiply by that. No, I already did that. Equals times 7.5375 exponent -2, and we get 7.49181.371 grams of zinc hydroxide. That's not coronavirus. That's my allergy to mama. So 3 3 sig figs are allowed, so you're going to say 7.49 grams of zinc hydroxide. That's your answer for 104. Did anyone get it? I would put $20. I'm afraid nobody got it. But you should try it. If I was a betting man, I would bet $20 that nobody did it. Or if they did it, they didn't get it. Am I right? All right, 105. A solution of sodium chlorate is prepared by dissolving 1.28 grams of the salt in water to form 1 liter of solution. To form a solution of sodium chloride of the same molarity and volume, what mass of sodium chloride would be needed? Okay, so first you got to find out what the molarity of the sodium chlorate solution is. Then you got to calculate the molar mass of sodium chlorite, which is a different chemical, and then produce a solution of the same concentration. So it's a 2-step calculation. You know, I'd be really happy if you're following along with me and you're getting this. But if you're not, you're actually in a situation which I cannot remedy. I can't remember. I don't think I gave you chapter 4 before I left. I should have. Maybe I did. I don't know. But chapter 4 is a continuation of chapter 3. It's not like the concepts are radically different. We're just applying them to solutions, and we're doing titrations. So it's essentially the same idea. Same idea as being recycled. Okay, 1.28 grams of sodium chlorate. Sodium chlorate is NaClO3. And they have 1.28 grams, and you produce a 1 liter solution. So we're trying to find the molarity of the solution. Remember that molarity is equal to number of moles over the volume. So let's find out what the molar mass of sodium chlorate is. So you got 22.98977 for the sodium, 35.4527 for the chlorine, and 3 times 15.394 for the oxygen. So sodium chlorate, you guys see, guys, I'm a little bit disappointed at the turnout. I have a class of 30 people in grade 11, and I think it's like 8 or 9 in grade 12. So there should be close to 40 people on line watching me, and right now I have 8. I see that you're watching them later. That's all right too, but it'd be nice to interact with you, you know, on the spot. 106.44067 grams per mole. And we used 1.28 grams, so we're going to say 1.28 grams divided 106, etc., grams per mole. Flip that bad boy over and you get 1.202547 86 times 10 to the minus 2 moles of sodium chlorate. So because it's dissolved in 1 liter of water, that ends up being the molarity. So if you want to see it, I'll do it. Molarity equals number of moles divided by the volume. Number of moles is 1.202 blah 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 times 10 to the minus 2 moles over 1 liter. So the molarity is, and I'm going to go to 3 sig figs, 1.20 times 10 to the minus 2 molar. Then the next phase of the calculation is to try to generate the same level. Okay, Mama, you're really consistent. When you want something, you don't give up.
The next phase of the calculation is to form a solution of the same molarity, but with a different salt. Now the salt that you're going to be making a solution with is sodium chloride, so same calculation, 22.98977 plus 35.4527 plus now 2 times 15.394 instead of 3 grams per mole. Or you know what you can do? It's a cool trick. Start with the 106 and subtract the mass of 1 oxygen atom. So you can do that too. 106.44067 minus 15.394, and that's going to give you 90. Point. Wait a minute. Yeah, that's right. 90.44127 grams per mole. So if you want to get a 1 molar solution, now you're going to need, if you're going to want 1 liter of a 1 molar solution, molarity is equal to number of moles over volume, and you want, you know this quantity, you know that quantity, you're going to need N. So N is equal to M times V. The M we found out was 1.2 times 10 to the minus 2. I just erased it, so now I don't know what it is. Let's see. .202. Times the volume, which is 1 liter. So you need 1.2025478 times 10 to the minus 2 moles of something that has a mass of that many grams per mole. So times 90.44127 grams per mole is going to give you 1.08. Of sodium chloride. So after sig figs, you're going to put 1.9 grams. And that's your final answer. You know what, I'm going to cut it there today because what you need to do is try this stuff yourself. You need to try it yourself. Let's say you try 112 and 113 for homework tonight, okay? Try that and see what you get. And then we'll pick it up tomorrow.